Good morning, everybody. I'm probably heading to sunny California. Sorry, don't mean to rub it in, but here we are. Yesterday we talked about graphing parabolas, but yesterday they were in a different form. They were in the y equals a times x minus h squared plus k. Today they're in what I call a standard form, okay, or a quadratic form is what the book calls it. So if we're going to graph this, we're going to need a few things. First of all, in your reading, you found that the vertex can be found by using the form x equals negative b over 2a. Hopefully you read that. A would be, in this case, 1. It's always the coefficient in front of the x squared. B is negative 2 and c is negative 8. So to find the vertex here, we're just going to go ahead and take a negative 2 over 2 times 1. So I've got a negative b is negative 2, over 2 times 1, because 1 is the a value. Okay, and obviously that's 2 over 2, right, which equals 1. So here's what we know about the vertex. The vertex has an x coordinate of 1. Now if I want the y value, or the y coordinate, I just plug the 1 in. So I'll take the 1 and plug it in, and alright, that's easy. Y is equal to a 1 squared minus a 2 times a 1 minus an 8. Alright, that's 1 minus 2 minus 8, which makes a negative 9. So that's the vertex. It's at 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now, what do? Well, then the next thing we do is we can just graph it from there. We've got at least that, but then there's a line of symmetry. A line of symmetry is a line that goes straight down. It always goes through the vertex. So my line of symmetry is like cuts the parabola right in half. So my line of symmetry always goes through the vertex, and it's a straight up and down or an x equal equation. Any line that's a straight up and down vertical line is an x equal equation. In this case, it's x equals 1. So the line of symmetry is always going to be an x equals equation, always, and it's always going to be x equals the value of your vertex, x equals 1. All right? Now, we need more points to graph it. So if we want to go to x-intercepts, what we're going to do is take and set our equation equal to 0, because where it crosses the x-axis is where y is 0. If I do that, if I take 0 equals my equation, x squared minus 2x minus 8, then what I want to do with that then is factor. There's got to be two answers. So I'll go parentheses, 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 parentheses. All right, I want to factor it x and x. X times x makes x squared. What times what makes negative 8? That would add up to a negative 2. Well, that's easy. Negative 4, positive 2. Negative 4, positive 2. When multiplied, negative 4 times 2 makes negative 8. And when added, negative 4 plus 2 makes the negative 2. Well, we're not done yet because we really want to take two factors. And when the two factors equal 0, what are their answers? So I'll take my x minus 4 and set it equal to 0. And my x plus 2 and set it equal to 0. And these are pretty easy to solve for. So obviously, if I move over the 4, x equals 4, and sure enough, that would make it 0. So over here, minus 2, and I get x equals negative 2. These are your zeros, or your x-intercepts. So my x-intercepts are at 4, 0, and at negative 2, 0. All right, I can graph that. 4, 0, 1, 2, 3, 4, and negative 0, negative 2, 0, 1, 2. Now, one more point would be nice, and then that last point is going to be the y-intercept. All right, to get the y-intercept, I'm going to just let x equal 0. So the y-intercept is where x is equal to 0, so y-intercept, let's let x equal 0. So if I plug in 0 in my original equation, obviously it's going to be negative 8, but you can see that y is equal to 0 squared minus 2 times a 0 minus 8. So sure enough, y is equal to negative 8. Let's write that as a point. We're going to write as 0, negative 8. You kind of knew that already when you looked at the graph. Now, the neat thing that I like about the line of symmetry is we have a point on the graph at 0, negative 8. It has a reflection on the other side of the line of symmetry. So I'm going to put a point right here at 2, negative 8, because it's reflected over my line of symmetry. All right, that's easy to graph, okay? Oh, kind of missed that. There it is. All right, there's my parabola. Pretty easy. Yes, you can probably get this on your calculator. However, we're going to do story problems here in a couple of days, and you're going to need to know how to do the negative b over 2a. Okay, let's turn the page. All right, here's another one. We're going to graph 2x squared minus 12x plus 13. Okay, let's do the same things. First of all, the vertex. The vertex, I'm going to use x equals negative b over 2a, right? A is 2, b is negative 12. So I'm going to go, all right, a negative 12 over a 2 times 2. 12 over 4, which is 3. Okay, so my vertex is 3 something. And to get the corresponding y value, just take the 3 and plug the 3 in for x, and we'll get its corresponding y value. Okay, so I'll have a y equals a 2 times a 3 squared minus 12 times 3 plus 13. That's a 13 plus 13. I'm just going to let my calculator do the work. Why not? I'm going to plug it in. Why do all the work and the calculator can do it for me? 2 times, whoops, that says cosine. 2 times 3 squared, subtract 12 times 3 plus 13, and I get an answer of negative 5, okay? And we'll graph this in just a bit. Line of symmetry, well again, line of symmetry is just the x value of the vertex. It's an equation, so the line of symmetry is simply going to be x equals 3, negative 5, okay? The vertex was 3, negative 5. All right, I'm going to circle those because I'm going to come back to those, okay? X equals 3, what am I doing? X equals 3. There we go. X-intercepts. All right. Now, to get the x-intercepts, if it doesn't factor, we're going to have to find it. And one way to find it is by finding the zeros on the graph, because the x-intercepts are also called zeros. Well, let's see if we can put it on the calculator. So if I go y equals, and I put in my 2x squared, subtract 12x plus 13. Let's go a normal window and see what happens. I do know 13 is going to be part of the graph, so maybe I'll make the window a little bit bigger. Let's see, let's go negative 10 to, and I'll make this maybe be 15. I know, I'm thinking 15 because I know 13 is on the graph. So let's graph it. Okay, there it is. Now, if it doesn't factor the zeros, we have a 0 here and a 0 here. Okay, you guys see it, the 0, there's one 0 right there. There's another 0 here, or my x-intercepts. So how are we going to find that? We're going to go to calculate. Remember how we do that? We're going to calculate, our little blue button, second calculate, and let's go to the zeros. Okay, number 2, see the 0? So we're going to calculate the zeros, enter. Now, it says left bound, which is a little tricky because if I take a look at this point, listen carefully. If I look at this point right here, I want to find, to the left of it is above it in this case. So, bring my cursor over. Don't use your up and down arrow, use your back and forth arrow. So, here I am above it, I agree, but I'm at the left of it. Lock it in and enter. Now it says right bound. So, if this is the 0 I'm looking for, to the right of it is actually below it. Use your back and forth arrows, not your up and down. And so right now I am to the right of it. Yes, I'm below it, but I'm to the right of it. Enter and guess. So here's my 0, about a 1.42. So I get a 0 of about a 1.42 comma 0. Now there's 2 zeros, aren't there? Let's get the other. Get that so you can see it. There you go. So the other 0 is over here. So again, we're going to go to calculate 0. Let's go second, calculate 0. Second, calculate 0. And let's get the other one. Now see, the other one's over here. So again, left bound in this case, left of this point is below it. The left of this point is below it. So move it over. I'm like kind of right about there. It is left of it. Enter. Right of it, to be right of it, you're going to be above it. Yes, it's above it, but it's to the right of it. Okay, again, use your back and forth arrows. Lock it in, hit enter, we get about a 4.6. So we got about a 4.58, maybe to be accurate. 58, comma 0. Okay, those are my zeros, or my x-intercepts, okay? X-intercepts. Now the y-intercept, well that's easy. The y-intercept is 13. Hopefully everybody agrees. The y-intercept is just 13, but it's going to be a 0, 13. Alright, I didn't put graph paper on this, but we can do it by hand. So if I try and do a nice, neat job, I'll draw a graph in like this, right? I know my vertex is at -5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I suppose if you had graph paper that'd help, but 3, -5 is about there, okay? My x-intercepts or my zeros are at 1.4, maybe about there, and 4.58. 1, 2, 3, 4.58, maybe there. I've got a y-intercept way up at 13. Well, I'll just guesstimate. We'll just call that 13. And let's just draw it in. Not very good. I'm not an artist. The last thing I like to put in, I really do like to put in my line of symmetry, which goes right smack down the middle of this thing like that. And that is my x equals 3. Okay, homework, just 3 problems, 15, 17, 34. You can work on your bottle rockets as well, but this needs to be done.